Let's study what is a divide and conquer technique for data structures and how the divide and conquer technique helps us to design an algorithm and various applications and programs which will help us to divide a particular problem into small sequences so that we can have an easy solution. So let's see divide and conquer in data structure. Now, divide and conquer is a top-down technique for designing algorithms. The algorithm that consists of dividing the problem into smaller subproblems, hoping that the solutions of the subproblems are easier to find than composing the partial solutions into the solution of the original problem. So here, it's a very simple implementation of dividing a main program into small subprograms or functions or procedures. The most well-known algorithms design strategy is design and conquer. Divide instance of problems into two or more smaller instances, solve smaller instances recursively, and obtain the solution to original large instance by combining these solutions. To implement design and conquer, the video which has already been uploaded stands for the merge sort algorithm. So the merge sort is an implementation of divide and conquer strategy. So you can kindly refer to the merge sort algorithm video to see how the divide and conquer actually works. Now, this is a flow graph for the divide and conquer strategy. There's a problem of the size n over here. This is any real world problem that is taken, and that problem is then divided into the subproblem 1 and subproblem 2 of the size n by 2. So whatever is the size n of the problem is divided into two halves. A solution to subproblem 1, a solution to subproblem 2. So both the solutions are found out recursively till both of them reach a final solution or a finite solution, and this happens recursively. So after that we combine these two, that is known as conquering, and the solution to the original problem is done. It generally leads to an recursive algorithm. Now, these are a few examples of divide and conquer strategy where all it can be used: sorting, merge sort and quick sort, binary tree traversals, binary search, and matrix multiplication, that is known as Strasson's algorithm. We'll be seeing all this in the videos. So, let's see how divide and conquer actually goes. The first implementation is a master's theorem, which is important. The master theorem concerns recurrence relations of the following form. This is the occurrence happens in the time Tn is equal to a Tn by b plus f of n, where a is greater than or equal to 1 and b is greater than 1. Now, what are these variables significantly hold? N is the size of any problem, so this is n over here. A is the number of subproblems in the recursion, that is how many times we can divide. And n by b is the size of each subproblem. So this is the size which is given. And f of n is the cost of the work done outside the recursive calls, which includes the cost of dividing the problem and the cost of merging the solutions to subproblem. So the divide and conquer strategy will help us divide it into various functions and then in the end merging the functions in the top-down strategy. Now, this is general divide and conquer recurrence master's theorem. The equation that we said, a t n by b plus fn, where fn belongs to theta n raised to the power of d and d is greater than 0. Now, master's theorem states that if a is less than b raised to the power of d, then the time function it belongs to theta n raised to the power of d. If a is equal to b raised to the power of d, then the time function for the master's theorem belongs to theta n raised to the power of d log of n. And if a, the number of occurrences, are greater than the total number of time taken up to the power of d, then tn belongs to theta n raised to the power of log b raised to the power of a. The same results hold with big O instead of big theta. Now, these are the three equations whose answer we're looking out for. If Tn is equal to 4Tn by 2 plus n, which gives Tn belongs to, then Tn belongs to theta n raised to the power of 2. Tn plus 4tn by 2 plus n square, then time function Tn belongs to theta n raised to the power of 2 log n, and if time function Tn is equal to 4tn by 2 plus n cube, then it belongs to theta n square. Now this is a general divide and conquer recurrence master's theorem. This is a generalized theorem which is used for implementation, and we will see the various videos which will be following that how the divide and conquer strategies will be used in implementing merge sort, quick sort, binary search and binary tree traversals. Thank you.